All right, so here I just want to talk about the guidelines for integrals involving powers of sine and cosine. Please pay attention. You're going to ask questions, and I want you to follow. So here are my three guidelines. The first two guidelines refers to when the powers of sine or cosine is odd. So for example, if you have sine to the power of 2k plus 1, 2k plus 1 is an odd number, right? If you have that multiply cosine of x dx, then you can rewrite it as sine squared of x to the power of k times cosine of n to the x, cosine to the power of n of x times sine of x dx, okay? The sine squared x, you can convert to cosine by using the Pythagoras identity. So the Pythagoras identity, just aside here, is sine squared of x plus cosine squared of x is equal to 1. So if you have a sine squared of x, you are essentially rewriting it as 1 minus cosine squared of x. So what you'll do is you'll have this as 1 minus cosine squared of x raised to some power, multiplied by cosine of some power, and then you're going to save your sine as your du. If the power of cosine is odd, then you're going to have to convert the cosine squared of x to sine, right? So it'll be 1 minus sine squared of x now, raised to some power of k, times sine of n of x, and then you save for your du, right? So again, using the Pythagoras identity, we said that sine squared of x plus cosine squared of x is equal to 1, right? If you rewrite this in terms of cosine squared of x, then the other side of the equation will just read as 1 minus sine squared of x. So when you have that 1 minus sine squared of x, it's going to be raised to the power of k. You will expand that out, multiply by sine of n. Then again, you save your cosine term for your du. Let's see, what else can I do? If both sine and cosine powers are even, it depends on the problem, and of course non-negative, you make repeated use of basically these double angle identities. So if you have sine squared of x, cosine squared of x is equal to 1. I think these are actually half angles. 1 minus cosine of 2x over 2, and 1 plus cosine of 2x over 2. So with these guidelines, I just want to do a couple of examples. The first one that I want to work on is the integral on the bottom of sine to the third power of x times cosine to the fourth power of x dx. So who has the odd power, sine or cosine? Sine. So you're going to rewrite sine as sine squared of x, and you're going to factor out a sine of x, right? So this integral can be rewritten as the following. I can zoom back out a little bit. Using our first guideline, this will be sine squared of x times cosine to the fourth power of x times the sine of x dx. Right? Essentially, I'm just pulling out a sine of x factor, where now I have sine to an even power, namely 2. Now, because it's raised to the second power, I can go ahead and convert it in terms of cosine, right? Remember, sine squared of x plus cosine squared of x is equal to 1. So that implies sine squared of x is equal to 1 minus cosine squared of x. So using our identity, this new integral is 1 minus cosine squared of x times cosine to the fourth power of x times sine of x dx. Now, what you're going to do is take cosine to the power of 4, cosine of x to the fourth power, and you're going to distribute it inside the parentheses. Okay? If you distribute this inside the parentheses, this becomes cosine to the fourth power of x. Now, if I take negative cosine squared of x times cosine to the fourth power of x, you just add their exponents. So we'll have minus cosine to the sixth power of x times sine of x dx. For this integral, we're very much almost done with it now, because when you get to this line, you got to use a u substitution. you're gonna let your u be cosine. Excuse me. So if I let u equal to cosine of x, then what is my derivative of cosine? Negative sign. So it's negative sine of x dx. If you look at our integral, do we have the sine of x dx? Yes, we do. We have a sine of x dx, but the only thing is that in our du, it has a negative. So we move the negative to the other side, right? So in this equation, all you got to do is just say negative du is sine of x dx. And now you can rewrite your integral where we left off in terms of u. This is now going to become negative on the outside of the integral of u to the fourth minus u to the sixth du. Can you integrate this? So the integration, so you just got to use the power rules. So you have negative of u to the fourth. Well, that's u to the fifth over 5. And then negative u to the seventh over 7 plus c. But what was my u? My u was cosine. So there's two things I can do here. I'm going to replace the u with cosines. And then I'm going to replace it. I'm going to distribute the negative inside the parentheses. So the first term will be negative, but the second term is going to be positive. There you go. So you have negative cosine to the fifth power of x over 5 plus cosine to the seventh power. Oops, my bad. Cosine to the seventh power of x over 7 plus c. And that's it. That would have been my answer. This is a nice quiz problem. Go ahead. What's your two questions?
So on the second to the third equal line from the top. From second to third, yeah.
Here?
Yeah, you take that step again.
Okay, so all I did was to go from the second line to the third line, just take cosine to the power of 4x and distribute it inside the parentheses. So it's like I'm doing distribution, but backwards.
Okay.
I'm multiplying cosine to the fourth by 1, followed by cosine to the fourth by negative cosine of cosine squared of x.
And why did you make u cosine?
I made u cosine because part of the rule says that when you have the odd factor of sine, that's going to be your du, sine of x dx. Okay. Let me see if I find another problem here real quickly. I'm just trying to go through my my textbook. Unfortunately, my phone unlocked. It went on sleep mode and then it refreshed. So 1 second.
Can you do one eight by chance?
What about definite?
Wait, hold on. Give me 1 second. So that was my first example, right? No, not again, man. Shit. All right, let me just see your example.
Cool. It's integral